Hi, welcome to Physics
Afterhours.
And this is our second video, so I hope you enjoy.
Alright, so here's our question. Our question states that we have a block on a frictionless table that is connected as shown in this figure right here to two springs having a spring constant K1 and K2, and wants us to find the expression for the block's oscillation frequency F in terms of frequencies F1 and F2 at which it would oscillate if the attached to is spring 1 or spring 2 alone. So basically what it's asking for is to be able to calculate these two frequencies alone and then put them together into one oscillation frequency expression. And we're going to be able to do that with our simple harmonic motion equation right here. And then we're going to plug that, or we're going to isolate the K's and plug it into our effective spring constant of a series, this equation down here, to find our expression with just F1s and F2s, because that's all that's important to us in this equation. And the reason why we're using the spring constant of a series is because this allows us to calculate when there's two different spring areas right here. That's why we have K1 and K2, and there could even be K3 or K4 if there are more like sections on the figure. So the first thing we're going to do is find the frequency of oscillation for each one alone. So we have the frequency oscillation for F1 or for K1 and F2 with K2. And we're going to isolate the K's, which is down here, where we have K1 equals 4 pi squared m times F1, and the same thing over here, just everything in F2 and K2. And then I also made it this here, which is the K net and the F net, so we could plug into this part right here. So at this point, we just use the effective spring series constant, and we just plug all the K's into the respective parts. K EQ I just used as K net, so we can, just so you guys know. And so down here we have everything just plugged in. We have the same things with our F net, F1 and F2. And now we just move the variables around and isolate the F's so we can find our expression in terms of F1 and F2. So here's the thing we have from the last step. So we don't the 1 over 4 pi squared m can be factored out because we don't really have to worry about that. All we're just trying to do is find the expression with the f's. So we can discard that part as well, and all we have to worry about now at this point is 1 over f net squared equals 1 over f1 squared plus 1 over f2 squared. At this point, we're just moving around the variables and just simplifying everything around. So what I did is I multiplied the denominators, f1 and f2, leaving us with 1 over f net squared equals f2 squared plus f1 squared over f1 squared times f2 squared. And then now that I have that, since we're trying to find f net, we just flip the fraction around, leaving us with f net squared equaling f1 squared times f2 squared divided by f2 squared plus f1 squared. And since we have f net squared, we want to square root everything, and then the square root cancels the two squared variables at the top, but just leaves the bottom with the square root. That leaves us with f net equals f1 times f2 over the square root of f1 squared plus f2 squared. And that's our expression for the block's oscillation frequency of f in terms of f1 and f2. And that's our answer.